All right, in the last few examples, we've had some really nice limits, nice points of intersection. Here we're going to look at a situation where we don't, and we're not going to be able to do these by hand. We're going to have to do them in the calculator, but that's the way of the world. We use technology for stuff these days. So got a couple here. Y equals x squared minus 4. Go ahead and put that in the calculator. X squared minus 4. And y equals cosine of x. So cosine of x. And I don't know as I've had the opportunity to say it this semester, but when you're doing calculus, you need to be operating in radians. So I'm going to make sure that I'm set to radians here. And I am. All right, if we look at a graph of these two curves, let me zoom in on the screen a little better. I think okay, we can see that they intersect at some point there and some point there, somewhere near positive and negative 2, but not exactly. So let's find that. Let's do second calc 5 for intersection, and then enter, enter, enter. And we'll see that that point of intersection is 1.914, give or take. And since they're both symmetric, that'll be on the left and the right hand side, negative and positive 1.914. So the integral that we're going to set up is going to be the integral from negative 1.914 to positive 1.914 of the top curve, which was the cosine curve, minus the x squared minus 4 curve. Make sure you put parentheses around that or distribute the negative dx. Okay, that's our setup, and that's pretty simple. If we want to do that in the calculator, all you got to do is go back to your y equals screen and put in cos x minus x squared, and then distribute that negative, so it would be plus 4. We don't need our second curve in there. It won't hurt to have it there, except it'll make the window a little uglier. And then we go back to our graph. And the graph we see is going to be very different. If you back up and look at what the graph was before, we had a shape that looks something like this. A cosine on top and a parabola on the bottom. Now imagine if that was made up of those little vertical rectangles that we talked about several times. And then it was turned up like this so that the table was there. And you allowed all of those little rectangles to drop down so the bottom edge was on the table. The shape that that would produce is the shape that we see here on the screen. And the x-intercepts of this shape correspond to the ends of that original region, the positive and negative 1.914. So to find this, simple. Second, calc, and then 7. Right? We want that area under the curve. Let's choose enter. It asks us for a lower bound. We could do negative 1.914. I think that was right, yes. And then it asks us for our upper limit. So we do positive 1.914. And it'll give us our decimal approximation of 12.52087, which is good for a few decimal places. We only put 3 decimal places in, so we're not going to get 4 or 5 decimal places accuracy out. Right? I don't need to write that down. I do want to comment, though, that if we wanted to, we could have just done, since it's symmetric, we could have just done the integral from 0 to 1.914 and then doubled it. If you want to save typing in a couple digits, it's possible to do that. You don't need to. It's not an advantage. Let's try one more. So y equals square root of x and x squared minus 4x. So let's look at the square root of x and then x squared minus 4x. We know what x squared looks like. X squared minus 4x will be a parabola. The point of intersection on the left is trivial. That's 0. The one on the right we don't know, though. So second trace down to 5 for intersect. And then enter, enter. If I hit enter again, it's going to give me the intersection at 0, 0. So I want to do second trace 5 enter, enter. But before I hit enter again, move that cursor so it's closer to the intersection I want it to find, and then hit enter a third time. I get 4.473. So 4.473. Again, to find the area of the region, we need to go back and put the top curve minus the bottom curve. So that'll be square root of x minus x squared, and then minus negative 4x, so plus 4x. And get rid of that second curve. And when we go back to our graph, we should see that region sort of slump down to the x-axis with our x-intercept of that number, 4.473, which looks about right, I guess, a little less than 4.5. And then we can do second trace 7 from 0 to 4.473. Color in our region and give us our decimal approximation of 16.49075. I think that should do it for that topic. We're going to move on to finding average value next time.